Alright, so we are going to explain the structure of the nitrite ion. Let us begin with the lowest structures of nitrogen and this oxygen over here. As we can see, we have drawn the valence electrons of each. The black dots represent the valence electrons for nitrogen, and the blue dots represent the valence electrons for oxygen. As we can see, oxygen has 6 and nitrogen has 5. Okay, so what is going to happen here? The nitrogen is going to make a double bond with the oxygen. 2 electrons from the nitrogen and 2 electrons from the oxygen. They are going to share in this covalent bonding over here. Then another oxygen will approach with its 6 valence electrons, and it's going to come nearby the nitrogen. Why is that? Well, oxygen is more electronegative than nitrogen, and there is one thing that we need to take into account in order to explain this. Nitrogen cannot have more than 8 valence electrons. That is, that in the second level there is a maximum of 8 electrons. Why is that? Because the configuration of nitrogen is 1s2, 2s2, 2p, 3. Let us remember that in 2p we can hold up to 6 electrons. That is why nitrogen cannot hold more than 8 electrons. It is not physically possible. So there is no way that nitrogen is going to make a double bonding here, or that principle would be violated. So what is going to happen in that case? Since oxygen is more electronegative, it will attract a pair of electrons from the nitrogen, these electrons, this pair. So that pair is going to be attracted, as we can see here, and a single bond that is covalent will be formed. These 2 electrons come from this nitrogen. Then, as I said, a single bond that is covalent bonding will be formed. Now, let us make sure that this oxygen over here fulfills the octet rule. So we are going to count the electrons very quickly. 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen over here fulfills the octet rule. Now, what about the one on top? The octet rule for this oxygen over here. So let us count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen fulfills the octet rule. But what about the nitrogen? Let's count. 1, 2, 3, 4, 5, 6, 7. Nitrogen only has 7 valence electrons. How is that possible? Nitrogen does not attain stability because it has 1 unpaired electron. In our case, it's electron number 7, remember? So it needs 1 electron to attain stability. That's why this ion has a negative charge of -1. It behaves as a free radical. It contains an unpaired electron in the valence shell. It is an exception to the octet rule. The nitrite ion is going to react with the potassium as an example. As we can see here, potassium is low in electronegativity, as an ionic bond will be formed, and we have potassium nitrate.